Hello, my friend. Welcome. Before we begin our journey tonight, take a moment to settle in. Adjust your pillow, pull your blanket up a little higher, and let your body sink into the mattress. Let the events of your day fade away, drifting off like leaves on a slow-moving river. Close your eyes, take a deep breath in, and as you exhale, let your shoulders drop. Tonight, we are going to travel far away from the noise of the world. We are going to a place where the earth touches the sky, a place of absolute silence and profound mystery. Imagine you are sitting in the passenger seat of a sturdy vehicle climbing a winding road in the middle of the Pacific Ocean. Outside, the air is changing. We are rising above the tropical humidity of Hawaii, climbing higher and higher until we break through the layer of clouds. Below us, a white ocean of clouds stretches out to the horizon, glowing softly under the moonlight. But above us, the sky is changing. It is becoming a shade of black, so deep, so pure that it feels like velvet. We have arrived at the summit of Mauna Kea. Here at 4,200 meters above sea level, the air is thin and cold. It is a dry, biting cold that nips at your skin, a sharp contrast to the warm beaches far below. The temperature here often drops to freezing, sometimes 0 degrees Celsius, or even lower. It is a stillness that you can feel in your bones. This mountain is a dormant volcano, a sleeping giant that has rested for thousands of years. To the native Hawaiian people, this ground is sacred. It is the realm of the gods, a place where the heavens meet the earth. And in this modern age, it has become a cathedral for a different kind of worship, the worship of knowledge and the stars. As you step out into the crisp night air, you see them, the great observatories. They look like giant white shells or perhaps silence mushrooms sprouting from the red volcanic rock. They are the eyes of humanity. Tonight, our destination is the Keck Observatory. It stands tall against the starlight, a massive white dome that houses one of the most powerful optical telescopes on our planet. Everything here moves slowly. The dome rotates with a low, heavy rumble, almost like the breathing of a great beast. Inside, the environment is strictly controlled. There are no bright lights here. The corridors are dim, illuminated only by faint red lights to preserve the astronomer's night vision. It feels like a submarine navigating the depths of the ocean, but instead of looking down, we are looking up into the infinite ocean of space. Let us walk into the control room. It is warmer here. The room is filled with the soft hum of computer servers and the quiet whirring of cooling fans. This is the heartbeat of the observatory. It is not like the movies where someone looks through a small glass eyepiece. Modern astronomy happens on screens. It happens in rows of numbers, in graphs, and in streams of data. The room is occupied by just a few people. They are the night watchmen of the universe. They sit in comfortable chairs wrapped in fleece jackets to ward off the chill of the high altitude. On the desk, there might be a thermos of hot coffee, the steam rising and curling in the pale light of the monitors. These astronomers are listeners. They are waiting. They have dedicated their lives to catching photons, tiny particles of light that have travelled for millions, sometimes billions of years, just to strike the mirrors of the Keck telescope tonight. Think about that for a moment. That light began its journey before humans walked the Earth, before the dinosaurs, perhaps even before our solar system existed. It has crossed the vast empty desert of the cosmos, avoiding dust clouds and gravity wells, only to end its journey here on this screen, in the quiet room on a mountaintop in Hawaii. The work is slow. It requires a patience that most people do not possess. The astronomers type commands into the computers, directing the massive 10-meter mirror to a specific coordinate in the sky. Then they wait. They watch the exposure time count down. 5 minutes, 10 minutes, sometimes an hour. They are fishing in a dark ocean, hoping to catch a glimmer of something new. Out the side, the wind howls softly around the dome, a lonely sound that emphasizes the isolation. You are miles away from the nearest town. There is no cell phone signal interference here, no city lights to pollute the view. Just the absolute darkness and the diamonds of the Milky Way stretching across the sky like a river of spilled milk. It is so clear you feel you could reach out and scoop the stars into your hands. The date on the computer screen in the control room reads August in the year 2025. It has been a routine summer. The nights have been clear, the atmospheric turbulence low. The seeing, a term astronomers use to describe the stability of the atmosphere, has been perfect. For weeks, the team has been conducting a standard survey of deep space objects. They are looking at a patch of sky that seems empty to the naked eye, but to the sensitive sensors of Keck, it is teeming with faint distant galaxies. The night shift is usually quiet. There is a rhythm to it. Target the telescope, start the exposure, wait, read the data, repeat. It is a meditative cycle, almost hypnotic. The hum of the machines becomes a lullaby. The world below the clouds feels like a distant memory, a dream you once had. Up here, only the universe is real. But tonight the rhythm is about to change. It happens at 3 a.m. The fatigue is just starting to set in, that heavy feeling behind the eyes that comes in the deep hours of the night. One of the astronomers, a woman who has spent 20 years watching these screens, leans forward. She adjusts her glasses. A new packet of data has just finished downloading from the camera sensor. Usually the raw data looks like a grainy grey image filled with static and small dots of light. But this time, as the software processes the information, a spectrum appears on the auxiliary monitor. A spectrum is like a rainbow. It breaks light down into its component colours to tell us what an object is made of. It tells us the chemical fingerprint of a star or a galaxy. Most spectra follow a standard pattern. Hydrogen lines here, helium lines there. It is a language astronomers read as easily as you read a book. However, the line on the screen tonight is different. It is not a glitch. The equipment is calibrated perfectly. The jagged line of the graph spikes in a way that does not make sense. It shows the presence of elements that should not be there in a combination that defies the standard models of stellar evolution. It is a whisper from the dark, a signal that stands out against the background noise of the universe. The room seems to get quieter, if that is even possible. The hum of the servers seems to fade into the background. The astronomer blinks, rubs her eyes and looks again. She types a quick command to verify the coordinates. The telescope is pointing at a region of space that was supposed to be unremarkable, a void between galaxies. But the data says otherwise. Something is out there. She calls her colleague over. "Look at this," she whispers. Her voice breaks the silence, sounding loud in the stillness. They both stare at the glowing line on the screen. It is a beautiful, confusing, impossible line. It is the first letter of a message they do not yet understand. Outside, the wind continues to blow over the frozen lava rocks of Mauna Kea. The stars continue their slow march across the sky. The world below the clouds sleeps on, unaware that on this lonely peak under the dim red lights of the control room, the door to a great mystery has just been cracked open. The data from August 20 to 25 sits on the screen waiting to be decoded. As we continue our drift through the velvet silence of the cosmos, we begin to witness a transformation. The lonely frozen traveller we met earlier, that icy rock drifting in the dark, is beginning to feel the presence of something greater. It is waking up. We are entering the domain of the sun. And here in the vast emptiness between planets, we discover that space is not actually empty at all. It is filled with invisible rivers and silent storms. This is where we learn the beautiful, steadfast rules of light and wind. When we think of wind on Earth, we imagine the rustling of leaves or the gale that pushes a sailboat across the water. It is the movement of air, but out here there is no air. Yet there is a wind, a relentless, powerful breath exhaled by the sun. We call this the solar wind. Imagine the sun not just as a glowing ball of fire, but as a fountain. It is constantly spraying streams of tiny charged particles out in every direction. These particles are the ghosts of atoms, protons and electrons streaming out into the dark at speeds of nearly 1 million miles per hour. It is a ceaseless, invisible storm that washes over everything in the solar system. At the same time, there is the light itself. We often think of light as something that simply allows us to see something intangible that has no weight. But in the laws of physics, light has substance. It carries momentum. When a ray of sunlight strikes a surface, it gives a tiny, almost imperceptible push. This is called radiation pressure. It is like a gentle, constant hand pressing against everything it touches. Now look at our comet. As it draws closer to the warmth, the ice deep inside begins to turn directly into gas, bypassing the liquid stage entirely. It sighs out clouds of steam and dust, releasing the materials it has held frozen for billions of years. This is where the magic happens. This is where the invisible forces of the cosmos paint a masterpiece. The dust and gas released by the comet do not simply hang around it like a fog. They are caught by the solar wind and the pressure of the light. Just as smoke rising from a chimney is caught by a breeze and stretched out into a long, thin line, the material from the comet is blown outward. This creates the magnificent tail of the comet. But here lies one of the most fascinating rules of our universe, a rule that defies our intuition on Earth. If you were running down a street with a long scarf, the scarf would trail behind you, tracing the path you have already walked. But a comet does not follow that rule. The tail of a comet does not necessarily point behind it. Instead, the tail always points away from the sun, always. Think of a boat floating in a fast-moving river. It doesn't matter which way the boat is pointing, the current will always rush past it in one direction. The solar wind is that river. It flows outward from the sun to the edges of the system. When the comet releases its gas and dust, that material is caught in the current of the solar wind and the pressure of the sunlight. So as the comet travels inward toward the sun, the tail streams behind it just as we might expect. But, and this is the beautiful part, as the comet swings around the sun and begins to leave travelling back out into the deep dark, the tail swings around too. As the comet moves away, the tail actually flies in front of it. The comet chases its own tail out of the solar system. It is strictly obeying the invisible traffic laws of space. The sun is the centre and the wind blows outward. The tail is simply a flag showing us which way the solar wind is blowing. There is a profound sense of peace in understanding this mechanism. It reminds us that this is a universe of order. For over 400 years, since the days of Isaac Newton and later through the genius of Albert Einstein, we have mapped these rules. We found that the universe is not a place of chaotic random magic, but a place of elegant, predictable structure. Newton gave us the understanding of gravity, the invisible tether that holds the comet in its long elliptical embrace. He showed us that the motion of a celestial body could be predicted with the precision of a clock. It is the same logic that causes an apple to fall from a tree in an orchard on Earth. The force that grounds us is the same force that guides the comet through the heavens. There is a unity in that, a connection between the small and the immense. Then came Einstein, who deepened our understanding. He taught us that light has a speed limit, a constant rule that nothing can break. He showed us that the gravity guiding our comet is actually the result of the sun, bending the very fabric of space and time like a heavy stone resting on a stretched sheet. The comet is simply following the curve of that fabric, sliding along the path of least resistance. These laws, from the push of the light to the curve of space, have held true for eons. They were true long before humanity looked up and wondered, and they will be true long after we are gone. There is a deep comfort in this reliability. When we look at the comet's tail stretching millions of miles across the black canvas, we are seeing a visual representation of these laws. We see the dust tail, often curved and yellowish, made of heavier particles that lag slightly behind, tracing the comet's path like crumbs dropped on a trail. We see the ion tail, blue and faint, made of electrically charged gas pointing straight as an arrow away from the sun, caught perfectly in the magnetic flow of the solar wind. It is a double-tailed signature written across the sky. It is like watching a stream of water flowing endlessly down a hill. It is consistent, it is reliable. It follows a script written in the language of mathematics and physics. In a life that can often feel chaotic and unpredictable, where our daily worries shift like sand, the physics of the cosmos offers a sanctuary of certainty. The comet does not choose where to point its tail. The sun does not choose when to release its wind. They simply are. They exist in a state of perfect obedience to the laws of nature. We can rest in this knowledge. We can find safety in the fact that we live in a cosmos that makes sense. It is a mechanism of exquisite precision, a grand clockwork where every gear and spring is functioning exactly as it should. The light pushes the gravity pulls, and the comet dances between them, balanced on the edge of these great silent powers. This creates a feeling of stability. We are not drifting in a void of chaos. We are passengers on a vessel that follows a charted course guided by the unbreaking rules of light, gravity, and momentum. Before we explore the mysteries that challenge these rules, we must first appreciate the safety of the rules themselves. We breathe in the order. We appreciate the structure. We watch the comet's tail flowing like a celestial river, always pointing the way, obeying the silent command of the sun, in a universe that is above all else, beautifully and perfectly consistent. October 18th, 2025. On the calendar, it was just another Tuesday, but up on the summit of Mauna Kea in Hawaii, where the air is so thin it feels like you are breathing pure clarity, time seemed to stop completely. This is the home of the Keck Observatory, a cathedral of science sitting above the clouds. The twin telescopes there are like two giant unblinking eyes constantly scanning the dark, looking for answers in the deep history of the universe. Usually the control room is a place of quiet routine. There is the hum of cooling fans, the soft clicking of keyboards, and the low murmur of astronomers discussing data. It is a comfortable rhythm. But on that night, the rhythm broke. It didn't break with a shout or an alarm, it broke with silence. A heavy, confusing silence that settled over the room like a thick fog. The telescope, specifically Keck 2, had been tracking a specific region of our solar system. It was looking at the flow of particles, the dust and gas that fills the empty spaces between the planets. For decades, every textbook, every model, and every observation has told us one simple truth: the sun is the master of this house. It pushes things away. The solar wind is a constant stream of charged particles blowing outward like a ceaseless gale, protecting us, defining the boundaries of our neighborhood. But the image appearing on the monitors that night showed something else. It showed the impossible. At first glance, it looked like a mistake. It had to be a mistake. The data showed a stream of matter, a ribbon of cold gas and cosmic dust, not moving away from the sun, but moving toward it. It was a river flowing uphill. It was rain falling upward from the ground to the clouds. It was a violation of the natural order that felt so wrong it made the stomach turn. This is what psychologists call cognitive dissonance. It is that mental pain you feel when your brain holds two conflicting ideas at the same time. Idea 1. The laws of physics are constant. Idea 2. The image on the screen is breaking those laws. When these two thoughts crash into each other, the human mind tries to reject the evidence. We try to rationalize it away. We say the machine is broken. We say it is a glitch. And that is exactly what the team did. They did not gasp in wonder. They frowned in frustration. They assumed the telescope was lying to them. In astrophotography and data analysis, you never trust the raw image. The raw image is dirty. It is full of lies and noise. So the team began the rigorous mechanical process of cleaning the data. This is a ritual every astronomer knows by heart, a method to strip away the errors to find the truth underneath. First, they looked for thermal noise. Even at the freezing temperatures on the mountain, the electronic sensors inside the camera generate their own heat. This heat creates fake signals, little bright spots that look like stars or energy, but are just the camera's own temperature. The team applied what are called dark frames images, taken with the shutter closed to subtract this heat noise. They expected the impossible stream of matter to disappear during this step. It did not. The stream remained bright and clear. Next, they checked for flat field errors. These are imperfections in the optical path. Maybe there was a speck of dust on a lens, or a shadow cast by a mirror support or a pixel on the sensor that was more sensitive than its neighbours. They used reference images to smooth out these bumps, essentially wiping the lens clean digitally. They were sure that this would fix the problem. They were sure the river flowing uphill was just a smudge on the glass. But when the process finished, the anomaly was still there. In fact, it was sharper now. Finally, they had to account for cosmic rays. These are high-energy particles from deep space that are constantly bombarding the Earth. When they hit a camera sensor, they create bright, jagged streaks or random sparkles that look very real. They are the snow on an old television screen. The computers ran complex algorithms to identify these random hits and scrub them out. They removed the chaos of the universe to see the signal clearly. This is the moment of a truth. This is when you know if you are looking at a ghost or a monster. They waited. The progress bar on the screen filled up. The software stripped away the noise, the heat, the dust, and the cosmic rays. What was left on the screen was pure calibrated reality. The room was absolutely still. The image had not vanished. It was undeniable. There, in the darkness of space, was a distinct organized flow of material. It wasn't a chaotic cloud. It was structured. And the Doppler shift measurements, which tell us if something is coming or going, were unambiguous. The numbers were negative, indicating an approach. The solar wind, that great protective breath of our star, was being over-PE'd. Something was pushing back. The tide had turned and the ocean of the galaxy was beginning to pour into our little island. The feeling in that room wasn't fear, not exactly. It was a profound, gentle, shivering sensation. It was the feeling of the floor dropping out from under you. It was the realization that the safety we took for granted, the outward pressure of the sun, was faltering. We often think of scientific discovery as a moment of cheering and champagne. But real discovery, the kind that changes the world, often feels like a haunting mystery. It feels like walking into your own house and realizing the furniture has been rearranged while you were asleep. The scientists looked at each other, their faces illuminated by the cool blue light of the monitors. The cognitive dissonance was fading, replaced by a heavy, awe-inspiring acceptance. The impossible had become the inevitable. They were watching a river flow uphill, and they realized with a quiet sense of wonder that they would have to rewrite the map of the world. The universe had changed its mind, and we were just there to witness it. So we had the signal. We had the numbers on the screen that had whispered of something impossible. But in science, seeing something once is never enough. A single observation is just a ghost. It is a shadow in the corner of your eye. To make it real, to make it true, you have to look again. And not just you need the world to look with you. This begins the great journey of verification. It is a process that feels less like a sprint and more like a slow, coordinated dance across the surface of our planet and into the silent vacuum above it. We needed to confirm that the universe was indeed breaking its own rules. First, we turned to the eyes that float above the clouds. Imagine leaving the solid ground of Earth. You rise up past the birds, past the high-altitude jets, until the blue sky fades away into a deep velvet black. Here, orbiting quietly around our world, is the Hubble Space Telescope. It is an old friend to astronomers. It has been up there for decades, a lonely sentinel watching the dark. The reason we love telescopes in space is simple. Down here on the ground, the air is thick. We breathe it. We live in it, but for a telescope, the atmosphere is a nuisance. It is like trying to read a book that is at the bottom of a swimming pool while the water is moving. The air shifts and shimmers. It bends the light. That is why stars twinkle when you look up at the night sky. To a poet, that twinkling is romantic. To an astronomer trying to measure the precise light of a distant galaxy, it is a disaster. But up there in the vacuum, there is no air. There is no wind. The vision is crystalline. The stars do not twinkle. They burn as steady, unmoving points of light. So we sent the command. A stream of binary code beamed up from a dish on the ground, travelling thousands of miles in a fraction of a second. The command told the telescope to turn, to pivot its heavy frame and point its mirror toward that specific empty patch of darkness where we found the anomaly. We waited. There is a unique kind of tension when you wait for data from space. You know the machine is working. You know the photons, those tiny packets of light, are hitting the sensor one by one, slowly painting a picture. But you cannot see it yet. You just have to trust the math and the machine. While the eye in space was gathering light, we needed a second opinion from the ground. We needed the giants of the Earth. Let's travel now to the southern hemisphere. Let's go to the edge of the Atacama Desert in Chile. This is one of the driest places on Earth. It looks like the surface of Mars. High up on a mountain peak, specifically Cerro Pachón, sits the Gemini South Observatory. It is a massive silver dome glowing faintly under the Milky Way. Inside there is a mirror over 8 meters wide. It is a masterpiece of engineering, a giant silver bucket waiting to catch rain from the beginning of time. Remember the problem with the atmosphere, the way the air blurs the image. At Gemini they have a brilliant way to fight this. They use lasers. Picture a powerful orange beam of light shooting out from the telescope straight up into the night sky. It creates an artificial star high in the upper atmosphere. The computers analyze how that fake star flickers and dances in the wind. Then the computer grabs the main mirror and bends it. It physically warps the shape of the glass hundreds of times per second to cancel out the distortion of the air. It is like noise-cancelling headphones, but for light. So there we were. One eye in the silence of space and another eye on a frozen mountain peak in Chile, fighting the wind with lasers, both of them stacked at the exact same coordinate. This is the moment where the human element becomes beautiful. You have to understand the universe is vast, but the community of people who study it is actually quite small. We are connected by a nervous system of fibre optic cables and high-speed internet. As the data began to flow in from Chile, it travelled down the mountain, across the continent, under the ocean floor, through thick cables and onto screens in Europe, in North America and Asia. It creates a feeling of profound connection. In a control room in Chile, an operator is sipping coffee to stay awake at 3 in the morning. In London, a professor is just logging on after breakfast. In Tokyo, a team of students is watching the readout late in the afternoon. We are all separated by thousands of miles by language, by culture and by time zones. But for this moment, we are all looking at the same thing. We are all thinking the same thought. This is the hive mind of humanity. We built a global brain to understand the cosmos. Then the results came in. We layered the images on top of each other. The crisp, perfect image from space. The deep, rich data from the mountain in Chile. We checked the light spectrum. We looked for errors. We looked for a smudge on the lens, a glitch in the software, a satellite passing by that might have confused us. We tried our hardest to prove ourselves wrong. That is the discipline of science. You try to break your own discovery. You attack it with logic and skepticism. But the data held her firm. The Hubble image showed the same structure. The Gemini data confirmed the chemical composition. The numbers lined up perfectly. There is a specific emotion that comes with this. It is the beauty of consensus. In a world where people argue about everything, about politics, about money, about what to have for dinner, there is something holy about a moment where the data forces everyone to agree. When 10 different instruments built by different nations using different technologies all look at the same impossible object and say, yes, it is there, the feeling is overwhelming. It is no longer a theory. It is no longer a mistake on a single computer screen. It is reality. We realized that the object was not just a glitch. It was massive. It was ancient. and it was emitting energy in a way that physics said should not happen. The atmosphere in the labs changed. The silence of uncertainty was replaced by the hum of intense focus. We were no longer asking, is it real? Now the question had changed. The question was now, what does it mean? We had used the eyes of the world. We had combined the clarity of space with the power of the ground. We had stitched together a picture using the collective intelligence of the human species, and that picture showed us a door where there should have been a wall. And as we stood there, metaphorically holding hands across the globe staring at this new reality, we knew that the hard part was just beginning. We had found the object, we had verified it, but now we had to explain it, and to do that we would have to abandon the safety of what we knew and step into the theoretical unknown. We were about to leave the map behind entirely. The date is October 3rd, 2025. We have left the blue skies of Earth far behind. We have travelled millions of miles through the dark, silent ocean of space to arrive at a different world. Here the sky is not blue, but a dusty butterscotch pink. This is Mars, the red planet. It is a world of silence. There are no birds singing, no wind rustling through trees, and no waves crashing on a shore. There is only the endless desert of red stone and the thin, cold atmosphere. But if you look up high above the rust-coloured surface, there is life. Not biological life, but mechanical life. Two silent sentinels are floating in the void. They are the creations of humanity, the ExoMars Trace Gas Orbiter, and the veteran spacecraft known as Mars Express. Usually these machines have a single obsessive focus. They look down, they scan the canyons and the volcanoes, they sniff the thin air searching for methane, searching for ghosts of water, searching for answers in the red dust. But today is different. Today a command has travelled across the emptiness from Earth. It took minutes for the signal to arrive, travelling at the speed of light, whispering to the computers on board. The command is simple but profound: turn away. Slowly, with the delicate firing of small thrusters and the spinning of reaction wheels, the spacecraft begin to rotate. It is a slow, graceful ballet performed in zero gravity. The cameras, which have spent years staring at the red ground, now tilt upward. They turn their backs on the planet that holds them in its gravity. They look out into the terrifying, beautiful open space. They are looking for the visitor. Out here, the feeling of loneliness is absolute. When we are on Earth, we feel held by our planet. We have the ground beneath our feet and the heavy blanket of air above us. But for ExoMars and Mars Express, there is no safety net. They are fragile boxes wrapped in gold foil and solar panels swimming in a vacuum that is hundreds of degrees below zero. They are tiny islands of metal and wire floating in a sea of nothingness. This fragility makes them beautiful. It represents the audacity of the human spirit. We are small, soft creatures living on a warm rock, yet we have built eyes that can see where we cannot go. As the cameras settle into their new position, the lens shutters open. The blackness of space is overwhelming. From this vantage point, without the thick atmosphere of Earth to scatter the light, the stars look like hard, unblinking diamonds. But the spacecraft are not looking at the stars. They are tracking a moving patch of light. The comet. On this day, October the 3rd, the comet is passing by. From the surface of Earth, it might be a beautiful smudge in the twilight. But here from the orbit of Mars, the view is spectacular. The spacecraft have a front row seat to a cosmic performance that will never happen again in exactly this way. It is a golden moment. In the timeline of the universe, which spans billions of years, this encounter lasts less than the blink of an eye. It is a fleeting handshake between a robot built by humans and a mountain of ice built by the birth of the solar system. The cameras capture the comet in stunning detail. They see the nucleus, the solid heart of the wanderer. It is a ragged, tumbling rock of ice and ancient dust, darker than coal, but shining brightly where the sunlight hits the fresh ice. They see the jets of gas exploding from the surface as the heat of the sun warms the frozen material. These jets create a glowing halo, a coma that surrounds the comet like a ghostly fog. And then there is the tail. From this angle, the spacecraft can see the structure of the tail stretching out for millions of miles. It is a river of dust and charged particles pushed away by the solar wind. It glows with an ethereal light, painting a streak of white across the absolute black of the background. The silence of the moment is profound. The spacecraft do not make a sound as they record this data. There is no shutter click, no whirring of film. There is only the silent stream of zeros and ones capturing the image of the ice mountain flying through the dark. This is the only chance. If the cameras fail, if the angle is wrong, if the command was received 1 minute too late, the moment is lost forever. The comet is moving at tens of thousands of miles per hour. It is not waiting for anyone. It is a traveller on a lonely path that loops around the Sun and heads back out into the deep freeze of the outer solar system. For a brief window of time, the Mars Express and the ExoMars orbiter are the only witnesses to this specific view. They are seeing the comet not as a distant star, but as a physical place, a chaotic world of its own. Think about the contrast. Below them is Mars, a planet that has been dead and dry for eons, a place of red dust and stillness. Above them is the comet, a thing of dynamic energy shedding its skin alive with the heat of the star it circles. And in between them, suspended in the void, are our machines. There is a deep melancholy in this scene. These machines are extensions of us, yet they are completely alone. They are millions of miles from the hands that built them. They will never return to Earth. They will never again feel the warmth of a laboratory or the touch of a technician. They belong to the void now. As the comet races past, moving away into the darkness, the moment ends. The golden alignment is broken. The geometry changes. The encounter is over. The computers on board verify that the data is safe. Slowly, the reaction wheels spin up again. The thrusters fire in short, silent bursts. The spacecraft begin their slow rotation back to their original positions. The cameras turn away from the stars. They turn away from the departing comet. They look back down at the familiar rusty face of Mars. The routine returns. They go back to sniffing the atmosphere and mapping the dust storms. But for those few hours, they were not just planetary explorers. They were astronomers standing on the deck of a ship in deep space watching a great white whale breach the surface of the dark ocean. The images they captured are now travelling through the vacuum. They travel as radio waves, silent and invisible, moving at the speed of light across the vast gap between Mars and Earth. In a few minutes, they will reach the giant antennas in Australia and Spain in California. Scientists will cheer. The world will see the pictures. But the moment itself, that silent physical proximity between the fragile gold foil machine and the ancient icy wanderer that belongs only to the emptiness. It remains there, a memory etched into the silence of the Martian orbit, a testament to the time when we looked away from the ground and found beauty in the dark. How do we touch the stars when they are so far out of our reach? How do we know what a distant sun is made of or what lies beneath the dusty surface of a wandering asteroid when we can never physically hold them in our hands? We cannot send a geologist to chip away a sample of a star. We cannot reach out and scoop up a cup of a nebula, and yet we know exactly what they are. We know their ingredients. We know their recipes. We know this because the universe speaks to us in light, and if you know how to listen, light carries a taste and it carries a scent. It carries the unique fingerprint of the chemical elements that created it. This is the magic of a science called spectroscopy. It is a long and heavy word, but the concept is beautiful and simple. Think of a rainbow. When sunlight passes through a glass prism or a drop of rain, it spreads out into a band of colours. Red, orange, yellow, green, blue, indigo, violet. But if you look very closely at that rainbow with sensitive instruments, you will see that it's not perfect. There are missing distinct thin black lines, gaps in the rainbow. These gaps are like a barcode. Every element in the periodic table, hydrogen, helium, carbon, oxygen, has a favourite colour that it likes to absorb. It eats that specific slice of light. So when we look at the light coming from a star or the sunlight bouncing off an object like 3i Atlas, we look for the missing pieces. We look at the barcode. If we see a specific pattern of missing lines in the red section, we know there is hydrogen. If we see a gap in the yellow, we might find sodium. In this way, astronomers become cosmic chefs. We can look at an object a million miles away and taste its chemistry. We can sniff the air of an alien world. We can read the biography of a rock written in the language of light. When we turned our eyes toward 3i Atlas, we expected to see a familiar recipe. We expected to taste the usual ingredients of the solar system. Most asteroids are like fruitcakes. They are messy mixtures of rock ice, silicon, magnesium, and a little bit of metal, all jumbled together by the chaotic gravity of the early universe. They are natural, random, and imperfect. But the light bouncing off 3i Atlas told a different story. The barcode was clean, too clean. The instrument screamed out two distinct names, iron and nickel. Now, finding iron and nickel in space is not by itself a miracle. These are the heavy ashes of dead stars. To understand why this is important, we must briefly look into the fiery heart of a star. Inside a star, alchemy is real. Stars are nuclear furnaces. For billions of years, they crush hydrogen atoms together to make helium. When the hydrogen runs out, they crush helium to make carbon and oxygen. They keep squeezing and heating, fusing lighter elements into heavier ones. But iron is the end of the line. Iron is the star killer. When a massive star creates iron in its core, it can no longer produce energy. The fire goes out. The star collapses and explodes in a supernova, scattering that iron and nickel across the galaxy. These metals eventually clump together to form planets and cores and asteroids. So yes, iron and nickel are natural, but in nature they are almost always found mixed with other things. They are covered in stoibin, they are oxidized, meaning they have reacted with oxygen to become rust. They are dirty. This is where the mystery of 3I Atlas deepens. The ratio of iron to nickel that we detected did not look like a random space rock. In a typical metallic asteroid you might find a chaotic mix. But on 3I Atlas the mixture was consistent, it was uniform. The specific blend of these two metals and the lack of other stony elements like olivine or pyroxene on the surface presented a puzzle. If you were to look at a piece of natural iron ore dug from the ground on Earth, it looks like a rough reddish-brown rock. But if you look at a steel girder used to build a skyscraper, it is shiny grey and strong. The difference is processing. To make steel you have to take the natural ore, melt it down in a blast furnace, remove the impurities and mix it perfectly. You have to refine it. The spectral signature of 3I Atlas looked less like the natural ore and more like the refined steel. It possessed a metallic sheen that suggested it wasn't just a rock with metal in it, but a solid slab of metal that had been possibly melted and reformed. In the cold vacuum of space, nature does not usually build blast furnaces to refine metal. Nature creates clumps and clusters. Nature creates variety. Nature creates rust. 3I Atlas appeared to be unrusted. It appeared pure. This brings us to a feeling that is hard to shake, the feeling of looking at a blueprint rather than a landscape. When we see a ratio of elements that mirrors the exact type of stainless steel we use in industrial manufacturing, specifically a type of austenitic steel, which is non-magnetic and incredibly durable against corrosion, we have to pause. Why would a random rock from the depths of interstellar space have the exact chemical composition required to build a ship hull that resists the harsh radiation of the stars? Usually when we analyze the light of celestial bodies, we feel a sense of chaotic beauty. We see the wild, messy art of the cosmos. But with 3I Atlas, the chemistry felt cold, it felt ordered, it felt precise. It is as if we were walking through a deep, wild forest surrounded by twisted trees and jagged rocks, and suddenly we stumbled upon a perfect polished chrome sphere sitting in the moss. The chemistry tells us it shouldn't be there. The alchemy is wrong for a natural object. We are left with the haunting realization that the universe is a vast chemistry set. Usually the reactions happen by chance, driven by gravity and time, but sometimes rarely the chemicals are mixed with such precision that it implies a mixer. It implies that perhaps this object was not born in the chaotic explosion of a dying star, but perhaps it was forged. The light from 3I Atlas continues to reach us carrying its silent message. It is a message written in the language of iron and nickel, a code of heavy metals that we are still trying to decipher. It tastes of industry, it smells of fire that was controlled rather than wild. And as we read this metallic signature, we cannot help but wonder if we are looking at a piece of geology or a piece of technology. The alchemy of the cosmos is usually a story of creation through destruction. But in this specific case, the alchemy feels like design. And that is a thought that keeps the astronomers awake long into the night, watching the numbers on their screens, waiting for the light to tell them one more secret. The Eye of Humanity, the James Webb Space Telescope, floats in the deep silence beyond the moon. It turns its golden mirrors toward the darkness, seeking the faint heat signature of our visitor. For days we have tracked the movement and the speed of 3I Atlas, but now we are trying to do something much more difficult. We are trying to taste the air around it. We are trying to read the chemical fingerprint hidden in the light that bounces off its surface. When astronomers analyze the light from a distant object, they are looking for missing colors. Different gases absorb light at specific frequencies, leaving dark lines in the spectrum. It is like reading a barcode at a supermarket. This barcode tells us exactly what the object is made of, even if we cannot touch it. As the data from the telescope began to stream back to Earth, translating into graphs and lines on screens in control rooms across the world, a silence fell over the scientists. They were expecting water ice. They were expecting the standard recipe of a comet from our own solar system. But 3I Atlas, true to its mysterious nature, refused to be ordinary. The data revealed a massive, overwhelming presence of carbon dioxide. To understand why this is so strange, we have to imagine what 3I Atlas actually looks like up close. In our solar system, comets are mostly dirty snowballs made of frozen water. But the surface of 3I Atlas is not water ice. It is something colder, harder, and more alien. It is a mountain of dry ice. On Earth, we use dry ice for stage effects to create heavy creeping fog, It is carbon dioxide frozen solid. It requires temperatures far colder than a normal winter to exist. Imagine standing on the surface of 3I Atlas. The ground beneath your feet is a blinding, translucent white glowing faintly in the starlight. It is slippery and brittle. If you were to drop a heavy stone, the ice might not crack, it might shatter like glass. This is a world where the air itself has frozen into a solid rock. This tells us that 3I Atlas was born in a place of unimaginable cold, far darker and more distant from its star than we ever considered. But then the telescope found the second part of the puzzle, and this is where the paradox begins. This is where the logic of ice and fire comes into play. Alongside the massive readings for frozen carbon dioxide, the sensors picked up a strong, undeniable signal for water. But it was not frozen water sitting quietly on the surface, it was water vapor. It was spraying out into the vacuum. This creates a contradiction that keeps astronomers awake at night. Usually a comet behaves in a predictable way. As it gets closer to a star, the heat warms it up. The ice melts or turns to gas, creating a tail. But carbon dioxide and water react to heat very differently. Carbon dioxide turns into gas at a much lower temperature than water. If 3I Atlas is covered in a shell of dry ice, that shell should be sublimating, turning into gas long before the water inside gets warm enough to move. And yet the data shows both happening at once. It is behaving like a geyser in the deep freeze. Imagine a pressure cooker buried inside an iceberg. The outer shell is frozen solid, a shield of dry ice that has survived the millions of years of travel between the stars. But deep inside, or perhaps in hidden pockets near the surface, there is water that is somehow being heated, somehow finding a way to escape. It bursts through the cracks in the dry ice shell, spraying out like a fire hose into the void. We are seeing jets of water vapor blasting out from a body that is technically too cold to have liquid water. It is a mixture of chemicals that shouldn't be stable together, not in this way. It is like finding a fire burning inside a block of ice without melting the ice. This leads our minds to wander back in time to the moment 3I Atlas was born. What kind of chaotic, violent nursery could create such a thing? In our own solar system, the planets and comets formed in a relatively organized way. There was a frost line, a specific distance from the sun where it was cold enough for water to freeze. Closer in, you get rocky planets like Earth. Further out, you get the gas giants and the icy comets. But the composition of 3I Atlas suggests it formed in a solar system that was being churned up a place of turmoil. Perhaps that it was born around a dying star or a binary star system with two suns pulling and pushing the dust clouds with their gravity. Maybe 3I Atlas formed in a region where the snow line was moving back and forth rapidly, freezing different layers of gas on top of each other. First a layer of water, then a sudden deep freeze that trapped a layer of carbon dioxide, then water again. A cosmic layer cake made of volatile explosives waiting for a heat source to set it off. Or perhaps it is a fragment of a destroyed world. Maybe it is not a comet at all in the traditional sense, but a piece of a frozen ocean from a planet that was ripped apart by the gravity of a passing giant. That would explain the odd mixture. We might be looking at the remains of a lost atmosphere frozen into a solid block and flung out into the dark. The sheer amount of carbon dioxide is the most haunting detail. It implies a loneliness that is hard to comprehend. Carbon dioxide ice sublimates, meaning it turns into mist very easily. For this object to hold on to so much of it for so long, it must have spent almost its entire life in the deepest shadows of the galaxy. It has not known the warmth of a star for eons. It has drifted in the spaces between systems where the temperature hovers just above absolute zero. Now as it enters our neighbourhood, it is reacting to the sunlight with a violence we did not expect. The fire of the sun is touching the ice of its surface and the dry ice of its skin, and the result is a beautiful, confusing display of chemistry. The telescope sees it as a glowing phantom. It is surrounded by a halo of gas that is part common fog and part toxic fume. It is a reminder that the universe is not uniform. We often assume that water and rock and ice behave the same way everywhere. We assume that other solar systems look like ours with the same rules and the same order. But 3I Atlas is proof that nature has a much wider imagination than we do. It is a traveller from a place where the rules of formation were different, a place where dry ice mountains float in the void and water hides like a secret treasure beneath a frozen poisonous skin. As we watch the spectral lines on the monitors seeing the signature of carbon dioxide spike and the signature of water vapour dance alongside it, we are not just looking at data. We are looking at a recipe from an alien kitchen. We are seeing the ingredients of a world that was never meant to be, or perhaps a world that is waiting to be born. The paradox of ice and fire is not just a chemical reaction, it is a story of survival. It tells us that this object has held onto its secrets through the vast, crushing emptiness of interstellar space, preserving a snapshot of its birth environment frozen in time, waiting for us to look up and wonder. It invites us to close our eyes and imagine that distant, freezing nebula, the dark womb where this strange child of the cosmos was created, amid swirling dust and the silent flash of newborn stars. Let us settle back into the quiet observation of the night sky. We have spoken of the speed of this visitor, and we have spoken of its silence, but in that silence there is a rhythm. There is a beat to its movement like a silent metronome drifting through the obsidian waters of deep space. To understand this object, we must understand how it moves. Not just its path across the solar system, but how it moves within itself. Imagine for a moment that you are floating in the void watching this traveller up close. It is not sitting still, it is dancing. Astronomers peering through their massive telescopes could not resolve the object into a clear picture. It was simply too small and too far away. To the most powerful lenses on Earth, Oumuamua was nothing more than a single pixel of light, a faint dot against the background stars. So how do we know what it looked like? How do we know it was shaped like a needle or a flattened oval? The answer lies in goes into the light. This brings us to one of the most patient and elegant practices in astronomy, the study of light curves. Imagine a candle flickering in a dark room. If the candle is steady, the light is constant. But if someone walks in front of it, or if the candle spins and reveals a darker side, the light dips. As the astronomers watched that single lonely pixel of light, they noticed something mesmerizing. The brightness did not stay the same. It pulsed. It would glow brightly, reflecting the sun's rays, and then it would dim, fading almost into invisibility before brightening again. This pulsing was not random. It followed a strict repetitive schedule. It was a cycle. By measuring the time between the brightest peak and the darkest valley, the scientists found the heartbeat of the object. They calculated a rotation period, 16.16 hours. Every 16 hours and 16 minutes the cycle would complete. This was the length of a day on Oumuamua. But this number told them much more than just the length of the day. It unlocked the secret of the object's shape. Think of a perfect sphere like a basketball spinning on a finger. No matter how it turns, it reflects roughly the same amount of light. A sphere does not dim and brighten dramatically as it spins. Oumuamua was different. The change in its brightness was extreme. When it was at its brightest, it was 10 times more luminous than when it was at its dimmest. In the language of the stars, this is a massive variation. It suggested that the object was not round. It was elongated, extremely elongated. Imagine a long flat piece of driftwood floating on the ocean. When the broad flat side faces you, it reflects the sunlight and looks large and bright. But when a wave turns it so that the thin edge faces you, it almost disappears. It becomes a sliver dark and hard to see. This is exactly what Oumuamua was doing. It was tumbling through the dark. The data painted a picture of a violent, chaotic beauty. This was not a planet spinning gracefully on an axis like Earth. This was a tumble. The scientific term is excited rotation, or non-principal axis rotation. Picture a bottle thrown into the air. It flips end over end, but it also rolls sideways. It wobbles. It is a complex, dizzying motion. Oumuamua was somersaulting through the solar system. This tumbling motion is significant. It tells a story of history and trauma. A simple, gentle spin usually implies a calm existence. But a tumble often means that something hit it. It suggests that a long time ago, perhaps in the solar system where it was born, this object was subjected to a violent event, a collision or a gravitational shredding that sent it reeling into the dark, spinning wildly like a distinct baton thrown by a cosmic juggler. And it has kept that tumble for millions, perhaps billions of years. In the frictionless vacuum of interstellar space, there is nothing to stop it. No air resistance to slow it down, no water to dampen its motion. It just keeps tumbling, preserving the energy of that ancient event, carrying the memory of its birth in its very rotation. As we visualize this 16-hour cycle, we must also look at the anomaly that puzzled the observers. We discussed before that Oumuamua accelerated as if it were a comet pushed by the gentle breath of releasing gas. Usually when a comet releases gas, when it outgasses, that gas acts like a jet thruster. And just like a thruster on a spacecraft, if it is not perfectly aligned, it will cause the object to spin faster or slower. If you attach a rocket to a spinning wheel, the speed of the spin will change. But here in the rhythm of the darkness, there was a mystery. The astronomers looked for a change in that 16.16-hour spin. If the gas was pushing the object to make it accelerate, surely the spin should have changed too. It should have spun up to the point of breaking apart or slowed down. Yet the data was murky. The spin did not seem to change drastically enough to match the acceleration we observed. It was another puzzle piece that didn't quite fit the standard picture of a comet. It was acting like a comet in its movement through space, but it was maintaining its rhythmic tumble in a way that defied easy explanation. It feels almost like a mechanical precision, a heavy tumbling solid object impervious to the sunlight that was trying to push it around. Let yourself feel the weight of that timescale. 16 hours. On Earth, 16 hours is a long workday or a deep extended sleep. For Oumuamua, it is one full rotation of its world. As it travelled through our neighbourhood, the sun would rise and set on its surface in this strange wobbling cadence. Imagine standing on the surface of that object. Because of the tumbling motion, the sun wouldn't rise in the east and set in the west. The sky would be a dizzying display. The stars would not move in circles. They would loop and twist across the black canopy. The sun would swoop down, then perhaps retreat, then dive below the horizon only to reappear in a different spot. It is a chaotic sky viewed from a lonely raft, but from our perspective, watching from millions of miles away, it becomes a steady pulse. Bright, dim, bright, dim. It is a cosmic clock, tick-tock. There is something deeply soothing about this predictability. Even in the chaos of a tumble, there is a pattern. Physics dictates the rhythm. Conservation of angular momentum, the law that keeps a spinning top upright, keeps Oumuamua dancing to its own beat. It is a reminder that even in the deepest, darkest voids of the universe, where there is no life and no sound, there is still order, there is still time. This object is a time capsule not just of material, but of motion. That 16.16 hour loop has likely been repeating for eons. It tumbled while the dinosaurs walked the Earth. It tumbled while the pyramids were being built. It tumbled while we invented the telescope. And it continues to tumble now, long after it has left our view, heading back into the eternal night. The light curve is our only connection to it. That graph, that simple line rising and falling on a computer screen, is the heartbeat of the interstellar traveller. It allowed us to see the invisible. It allowed us to close our eyes and visualize the long red rocky shape turning over and over, untethered and free. So as we let the image of the spinning visitor fade, we are left with the sensation of the rhythm, the slow heavy turn of a traveller that has nowhere to be and forever to get there. A rhythm that belongs entirely to the darkness. For a very long time we believed that our solar system was a lonely island. We thought of our sun as a solitary campfire burning in the middle of a vast empty desert. We knew there were other stars, of course, but they were so incredibly distant that we felt safely isolated from them. We assumed that whatever happened in the chaotic voids of deep space stayed there. We thought that the gravity of our sun created a high wall, a border that kept our planet safe and kept the rest of the galaxy out. But that illusion of isolation was shattered not by an invasion fleet, but by a rock. To understand the sheer impossibility of Atlas and to understand why it frightens us so deeply, we have to look back at the guests who came before it. We must remember the brief history of interstellar visitors. It is a very short history, but it tells a story of escalation, a story that has led us directly to this moment. The first crack in our wall appeared in October of 2017. That was when the object known as Oumuamua tumbled into our view. It was the first time in human history that we confirmed an object passing through our neighbourhood had not been born here. It came from the darkness between the stars. Oumuamua was a riddle wrapped in sense. It was small, perhaps only a few hundred meters long, but its shape was baffling. As it reflected the sunlight, it seemed to stretch out like a long, thin cigar, or perhaps a flattened pancake tumbling end over end through the vacuum. It was a dark red shard, ancient and weathered by millions of years of exposure to cosmic radiation. But its shape was not the thing that kept astronomers awake at night. It was the way it moved. As Oumuamua passed the sun and began its journey back out into the dark, it did something that defied the simple laws of gravity. It accelerated. It moved faster than gravity alone could explain. Usually when a comet speeds up like that, it is because ice is melting and shooting out jets of gas acting like a natural rocket engine. But Oumuamua had no tail. There was no cloud of dust, no visible gas. It simply pushed itself away from the sun silently and invisibly. Some said it was a nitrogen iceberg. Others, more daring, whispered that it looked like a light sail, a piece of artificial technology catching the wind of the sun. We never found out the truth. It moved too fast, disappearing into the night before we could answer the question. It left us with a sense of unease, a feeling that the galaxy was stranger than we imagined. Then 2 years later, in 2019, the second traveller arrived. We called this one Borisov. If Oumuamua was the mysterious stranger in a trench coat, Borisov was the familiar neighbour. It looked exactly like the comets we have in our own solar system. It was a dirty snowball shedding gas and dust as it got close to the warmth of the star. We analysed its chemistry and it felt comforting. It contained carbon monoxide and water, the same building blocks we find at home. Borisov was important because it calmed our nerves. It told us that generally speaking, other star systems are similar to ours. They make comets, they make ice, and sometimes they throw those snowballs out into the dark. Borisov was normal. It followed the rules. It led us believe that Oumuamua was just a one-time freak event, a coincidence that would not be repeated. But now we have Atlas, and Atlas has broken every rule that Oumuamua bent and Borisov followed. When we compare these three travellers, we begin to see a pattern that is both awe-inspiring and terrifying. Oumuamua was like a piece of driftwood, a quiet anomaly. Borisov was a standard rock, but Atlas is a mountain. Atlas is not tumbling helplessly, it is marching. Think of the difference in scale. The first two visitors were small, fragile things that could burn up or break apart if they got too close to a star. Atlas is dense, it is heavy. It carries a momentum that suggests it is not just a random piece of debris floating in the current. The most disturbing difference lies in the trajectory. Oumuamua was fast, but its path was somewhat chaotic, tossed around by the gravity of the stars it passed. Borisov was on a classic hyperbolic curve, a smooth line in and a smooth line out. But Atlas is moving with a precision that feels unnatural. As we discussed before, its speed is consistent. It is not reacting to the sun's heat the way a comet should. It is not tumbling like a dead rock. It is cutting through the plane of our solar system like a bullet cutting through smoke. This trio of visitors, the mystery, the normalcy, and the monster, teaches us a lesson about the Milky Way galaxy. It teaches us about diversity. For decades we assumed interstellar space was empty. Now we know it is full of things. And the terrifying part is not that there are objects out there, but that they are all so different from one another. If the galaxy only threw comets like Borisov at us, we would be bored, but we would be safe. We would know what to expect. But the galaxy has thrown us three completely different objects in less than a decade. This implies that the darkness between the stars is not a void. It is a junkyard. It is a graveyard. And perhaps it is a highway. It suggests that the variety of objects wandering the deep space is limitless. There are shards of nitrogen ice, there are crumbling comets, there are metallic asteroids, and there are things like Atlas objects that sit right on the razor's edge between natural phenomenon and artificial construct. We are realizing how small our perspective has been. We are like a microscopic organism living in a single drop of water, thinking that the entire world is made of water. Then suddenly we see a pebble fall in, then a leaf, and then a piece of plastic. We realize the world outside our drop is vast, complex, and completely indifferent to us. Atlas forces us to confront the scale of our history. We have been looking at the sky with telescopes for only 400 years. We have been scanning for asteroids for only a few decades. In the timeline of the universe, we have barely opened our eyes for a fraction of a second. And in that fraction of a second, look what has walked through the door. If Oumuamua was a whisper and Borisov was a sigh, then Atlas is a shout. It reminds us that our solar system is not a fortress with high walls. It is an open plaza. It is a crossroads. We are not the masters of this domain. We are merely the current tenants living on a small rock near a stable star, watching the giants of the galaxy pass by in the eternal night. The arrival of Atlas changes the context of the previous two. We can no longer look at Oumuamua as a funny coincidence. Now it looks like a scout. We can no longer look at Borisov as just a rock. Now it looks like the camouflage. And Atlas looks like the main event. The galaxy is not empty. It is crowded. And as we watch this new, heavy, silent object glide past the orbit of Jupiter, moving with the unstoppable weight of a freight train, we have to ask ourselves what else is out there hiding in the dark, waiting for its turn to visit. To understand the journey of 3i Atlas, we must leave the warmth of the fire. We must leave the familiar neighbourhood of our solar system with its bright yellow sun and its family of planets. We must go to the place where the map ends. We must go into the deep, quiet ocean of the night. Scientists call this place the interstellar medium. It is a fancy name for the space between the stars, but to a traveller like 3i Atlas, it is simply the Great Silence. Imagine the moment millions of years ago when this object was finally pushed away from its home. Perhaps it was a large planet in its original system that gave it a gravitational kick, sending it flying outward. The light of its parent star grew smaller and smaller. It went from a blinding sun to a small coin in the sky to just another bright star, and finally it faded into the background of the galaxy. This is where the true journey began, the journey through the void. When we look up at the night sky, space looks empty. It looks like a perfect vacuum. But the space between the stars is not truly empty. It is filled with a very thin, invisible fog. It is made of gas and dust, the leftovers from stars that died long ago, and the building blocks for stars that have not yet been born. However, this fog is incredibly thin. Here on Earth, the air we breathe is thick with atoms and molecules, but out there in the deep void, you might find only one single atom in a space the size of a sugar cube. It is a ghost of an atmosphere. 3I. Atlas moved through this thin mist not for years, not for centuries, but for epochs. It is hard for us to truly understand the loneliness of such a journey. We are creatures who measure time in hours, days, and years. We get impatient waiting for a traffic light to change. But out there, time behaves differently. In the void, time is not a ticking clock. It is a vast frozen ocean. For millions of years, nothing happened. There was no sunrise, there was no sunset. There was only the eternal blackness and the distant, unblinking eyes of the stars. 3I. Atlas tumbled slowly in the dark, a silent mountain of ice and rock drifting without a rudder, without a destination. It was a message in a bottle floating in the largest ocean imaginable, waiting for a shore that might never appear. In this deep darkness, it is also unimaginably cold. Far away from the heat of any star, the temperature drops to the lowest limits of nature. It is the kind of cold that stops almost all motion. Out there, the temperature hovers just a few degrees above absolute zero. This is the temperature where even atoms hesitate to move. This extreme cold acted as a preservative. It put 3I Atlas into a deep sleep. The ices inside it, water ice, carbon, monoxide, ice, nitrogen. Ice became as hard as rock. The object became a time capsule. It held within its heart the secrets of its birth, frozen, perfectly protected by the chill of the void. It carried the chemical history of a solar system we will likely never see locked away in a cryogenic slumber. But even in the empty darkness, V's 3I Atlas was not entirely alone. It was being watched, and it was being touched by the invisible forces of the universe. Space is filled with something called cosmic rays. These are not rays like sunlight. They are tiny invisible particles, mostly protons and atomic nuclei, moving at nearly the speed of light. They are like a microscopic rain that never stops. They come from exploding stars, from black holes, and from violent events across the galaxy. For millions of years, as 3I Atlas drifted in the silence, it was constantly bombarded by this invisible rain. You might think that a rock floating in space would stay the same forever. But this cosmic radiation changes things. Slowly, over millions of years, these high-energy particles struck the surface of the comet. They broke the chemical bonds of the simple ices on its skin. This process is a slow cosmic weathering. It is like the wind smoothing down a mountain, but it happens on a molecular level, upshore. This radiation cooked the surface. It turned simple carbon compounds into complex, dark, tar-like substances. This is why, if we could have seen 3I Atlas as it travelled, it would not have looked like a bright white snowball. It would have looked dark, it would have been reddish-black like a piece of charcoal or dark asphalt. This dark crust was the scar tissue of its long journey. It was a protective skin formed by the harsh environment of interstellar space. It wrapped around the pristine ice inside, hiding the bright heart of the comet beneath a cloak of shadow. Think of the patience required for this journey. While 3I Atlas was drifting through the gap between the stars, entire species rose and fell on Earth. Dinosaurs walked the land and then vanished. Mountains on our planet were pushed up by tectonic plates and worn down by rain. The continents drifted apart. All the while, this lonely traveller continued its silent straight line through the dark. There is a profound beauty in this isolation. In our busy lives, we are constantly connected, constantly surrounded by noise and information. But 3I Atlas represents the opposite. It represents absolute solitude. It is a testament to the vastness of the container we live in. It reminds us that the universe is mostly quiet, mostly dark, and mostly empty. And yet within that emptiness, there is momentum. After eons of drifting, the scenery began to change. It was a subtle shift at first. One star in the distance, a star that was just an average yellow dwarf, began to grow brighter than the others. Gravity, the long arm of our sun, began to gently reach out into the interstellar void. It was a weak pull, a whisper of attraction across light years, but it was enough. Three-Eye Atlas, which had wandered freely for so long, was now falling. It was falling toward a new fire. It was falling toward us. The emptiness of the interstellar medium began to give way to the outer edges of our home. The density of the gas increased slightly, the temperature rose by the tiniest fraction, the darkness was no longer absolute, the traveller was waking up. The long night of the interstellar void was coming to an end. The frozen statues of ice inside the comet began to feel the first faint warmth of a new star. The silence was about to be broken. After surviving the cold, the radiation, and the crushing loneliness of the space between the stars, Atlas was about to enter the most violent and beautiful phase of its existence. It was arriving at our doorstep, a ghost from the deep past, ready to tell its story to anyone who was looking up. We are not alone. We have never been alone. We have the company of 1 trillion worlds. We have the company of our own curiosity, and we have the company of our dreams. Sleep now. Let your mind float free among the constellations. Let your dreams be filled with the beauty of the cosmos, with the colours of nebulae and the light of distant suns. The universe will still be there when you wake up ready to share more of its secrets. But for now, rest. Rest in the knowledge that you are part of something magnificent. Good night to the stars, good night to the Traveller Atlas wherever it may be, and good night to you.